Hey guys, so I taught this class on Maven and I felt it would be cool to kind of have a version of it on this YouTube channel. So today we're going to be learning about a decision framework that would help you to know the type of agent you should be building. Let's say your manager, your CEO or client just comes up to you and says, yeah, we need to solve this problem with an agent. We need to solve this problem with an AI agent. How are you going to know the type of agent to build? Yeah, what type of agent are you going to be building? Would a simple tool calling agent be good enough? Does the problem even require an agent? And if it doesn't require an agent, how do you get to convince your very AI hyper enthusiastic manager, CEO or client that you don't need an agent? How do you get to convince such person? So we're going to be looking at a decision framework that will help you match your problems to the type of agent you should be building, because the solution is already in the problem. Yeah, the solution is already in the problem. So if you don't know the solution yet, at least one thing you know is the problem, because that is basically what your manager is telling you to solve. So we're going to be learning a decision framework that basically maps problems to agentic solutions or no agentic solution at all. Let me get the lasso tool so that I can start moving something on the screen. Okay, I think we can bump this up a little bit too. Okay, good. Now, before we look at that decision framework, let us first look at the solutions that are available. What type of AI applications can we build today? What type of LLM applications can we build today? Once we have a good grasp of the solutions, we can then see how the problems map to the solutions. Now, the very first type of solutions, and we just have four. No matter how you try to look at it, no matter how you try to look at every type of agentic solution out there, there are basically four different types. And the very first one is simple LLM API calls. Yeah, just making a simple LLM API call. You just get a prompt and shoot it to OpenAI's API, Anthropic's API, or even Gemini if you are into that. You just make a simple API call, your prompt to the LLM provider's API, and get a response back. Now, this is good when you want to do things like content generation, text analysis, summarization, classification, or you want to transform text, even if it's an entire document. In this case, you don't want to perform any action. You don't have any action that you want to perform. It's just text in, text out. No tool usage. You're not performing any action. You're not making any side effects in the real world. So you don't need tools. All you want is to push in text and you want it to give you a textual response. And this is best for textual tasks where you know that the answer is contained within the LLM's knowledge. Even if that knowledge has a cutoff date, you know that you have that contained in the LLM's knowledge. For example, if you're asking a history question, I believe LLMs are very, very good at history. So you can definitely do that. If you're asking a question about Python, if it's not like the cutting edge, most recent Python version, you definitely find it in the knowledge base of any state-of-the-art model out there. So if what you want is to process text, probably you want to summarize an entire document, you want to write a poem, you want to draft a story, all those things, you can simply use a simple API call. If you don't need to go and get any type of knowledge externally, you can just use a simple API call. So that's the very first solution, a simple API call. The next type of solution is a single React agent or a single agent. You might be using a different pattern from React, but React is the most dominant pattern. A single agent. You have a prompt and you send it in. Probably you want to perform a task, let's say book a flight. The LLM is going to reason through the process. It's going to detect that it needs to call a tool. It's going to call the tool. Then it would get the results and observe the results. Then it comes to this decision juncture. There's always a criteria for this type of system, a criteria that checks if the expected outcome has been achieved. So when the LLM observes the results, it checks, has the goal been achieved? If yes, then it just sends a response to the user. And if no, it continues to reason about it. It reasons about it, the text needs another tool call, then it will make the tool call, get the results, observe again, check that gate, check that task completion gate. If the task is complete, if the goal is achieved, sends a response. If not, it reasons again and it goes on and on and on until it achieves this goal. Even though most of the time you are expected to have some sort of a threshold here, but like it can be a step count, it can be a step budget, and it can also just say, well, if you just notice this type of answer in the result, just send it back, because you can't have this loop running forever. So this is the second type of solution. You can reason, can plan, take actions and continue to iterate on that until the success criteria is met. This solution is applicable to situations where the solution part is generally known but just requires some flexibility in execution. For example, like I talked about the flight booking, we all know how to book a flight. You go to the flight booking site, you go to the booking form, and you book the flight. But you might need some flexibility in, let's say, comparing prices. You might want to go to different websites and compare prices. So you know the steps, you kind of know the path to solving a flight booking problem, but you want to be able to have some flexibility in exploring some sort of options. So this single agent, especially the React pattern, works with this. And for your tools, a maximum of 10 tools is good before you start confusing the model. Once you have more than 10 tools, you kind of want to break this down into a multi-agent system and distribute the tools. But yeah, if you have like 10 tools or lower, yeah, this also works. That's also a criteria to pick this. And this is suitable when the complexity doesn't warrant, coordination of multi-agents. When you have a single thing you want to achieve, let's say you want to just set up a calendar meeting. Yeah, sure. You can have a single agent, just set up a calendar meeting. You don't have to have a group of agents forming a multi-agent system to solve that. So if your task requires a tool, the execution, or rather the solution part, is kind of known, but you just need some flexibility. You don't have more than 10 tools and you don't need multiple agents, then a single agent is good enough. So that's the second type of solution. Now let us look at the third type of solution. Now the third type of agentic solution you would see out there is what is known as the workflow multi-agent. Now, I want to mention at this point, because some people might jump into the comment section and give their opinions, which is very, very allowed and even encouraged. I want to say that the nomenclature might not be there's nuances based on nomenclature. So some people might decide to call a workflow multi-agent something else, some other solutions something else, but this is just a general naming strategy I have adopted for this type of solutions. But these are the shapes of solutions you'll find out there. Yeah, except we discover a new one. So yeah, the next one is workflow multi-agent. You have a group of agents that are working together to achieve a particular result. Group of agents working together to achieve a particular result. You can have some branching between these agents, but one main characteristics of this multi-agent system, this is a multi-agent system, so you kind of know that you have multiple agents working together. When you use a workflow multi-agent, it is because you know what the flow looks like. Yeah, the sequence is predefined. There is a predefined sequence of steps to achieve that result. Like I said, there might be some branching, but you kind of just know all the parts. You kind of know the parts that even the branches are going to end up. There can also be some aggregation in between, but the path is defined. The solution is known. You see the work handed from one agent to another, mostly in a sequential fashion, some hierarchical. So let's say like an ETL process, extract, transform, and load process, or a document processing process. These are defined steps, but each step requires expertise in a certain domain. So that's why you kind of break it up into different agents. So you know the workflow ahead. You need agents to be focused on different domains. You use a workflow multi-agent. It is best for standardized processes with distinct phases. Like I said, like an ETL process, in a data pipeline, or a document processing process, or even a content generation pipeline where you, let's say you draft an outline, you do your research, then you write the article, then you publish the article and all that. Or you can even have some sort of review step. You review the article, then you publish the article to different platforms. As long as you know the steps, but you need different focus, you have different stages with different focus, use a workflow multi-agent. So that's the third solution. Now let us move to the fourth solution. So the fourth solution is what I call the autonomous multi-agent. Similar to the workflow multi-agent, you also need agents specializing in different domains. You want your agents to specialize in different domains, but you don't know the solution steps ahead. Yeah, the agents are responsible for collaborating and figuring that out. Yeah, that is this system. There is no defined pattern. Typically, there's always like an orchestrator but sometimes they might just operate in some sort of swarm or like a peer-to-peer system. Yeah. So you can have an orchestrator like this one as a planner agent that draws up the plan, then different agents get to run the steps. But it might just be a peer-to-peer system, might be a diamond kind of a communication channel that each agent can talk to each other and they just kind of figure it out. Even there might be handoffs. There might be like an handoff process. Like in my multi-agent course for LangChain, the handoff pattern is one of the systems whereby there's no central coordinator. The agents just kind of figure out who is next to take up the next step in the task, and they just pass it to that particular agent. But when you have a sub-agents pattern, that's LangChain's nomenclature. If you have something like a sub-agents pattern, you have this central coordinator that just kind of orchestrates the sub-agents and just aggregates or collects their results and determines the next agent to call until the final goal or the overall goal is achieved. So yeah, if you don't know the solution ahead, you need a multi-agent system. If you don't know the solution ahead, you need a multi-agent system. It also has to be a complex problem that requires multiple agents working together. A typical example is bug fixing, and we kind of did that. It's one of the projects in my multi-agents course that is linked in the description. We built a web troubleshooting multi-agent system. So there are different types of agents. There's a network agent, there's a front-end expert, there's a back-end expert. So whenever you give the multi-agent system any type of bug, it kind of just picks, who's going to do this, who's going to do that, who has to pick this. I think it's a skills pattern. Yeah, we use a skills pattern to kind of set that up. So the agents, they explore different options. When you need exploration, you use an autonomous system. So they explore different options, and the planning, every single plan cannot be known ahead. So it's kind of emergent. The planning is emergent. It emerges as more results come up from this agent. So you see new steps arising from discoveries during the agents executing their tasks. And this is just beautiful. This is a beautiful system, even though it's also the most complex, but it's beautiful, especially for open-ended problems like R&D, complex debugging, like I said with the one that we built in the multi-agent course. You have strategic analysis or something like app development. Let's say you want to build a mobile app. You want to build a mobile app and you just want to be able to dump your requirements to an agentic system for it to build for you. We see things like Cloud Code doing that. You need an autonomous multi-agent because the agents are going to coordinate themselves to plan out the project, to build it out. You have a back-end agent communicating with a front-end agent, a UI agent, and they're just having all this communication and making sure that they're in sync to produce, let's say, a very standard usable iOS application. So app development is also where you use this type of agentic system. So yeah, those are the 4 solutions. You have the simple LLM call. You have the single agent where we looked at the React pattern. We have the workflow multi-agent where you know the solution part ahead, but you just need different agents to focus on different domains. And we just looked at the autonomous multi-agents where the agents basically coordinate themselves to solve a problem. But I promised you a decision framework, and that is definitely what we're going to be looking at next. So these are our decision framework, and we're going to be walking through this. Yeah, these are all charts. To know what type of AI application should we be building. What type of AI application should you be building? By the way, I'm going to try and link. I think I have a GitHub link for this decision framework now. I'm just going to link. I think it also contains the images that we looked at earlier. So I'm just going to link that in the description also if you want to check it out. So what type of AI application do you need? What type of AI application do you need? The first question you ask yourself is, does the task require actions beyond text generation? Does it require actions beyond text generation, or text generation would fix it? Now, does it require tasks? Does the task require actions beyond text generation? If it is no, if it doesn't, then just use a simple model, a simple LLM call. That's what we tag that simple model. Just use a simple LLM call. You see, one thing about agentic systems is that you really have to start lean. Yeah, you really have to start lean. Let the complexity come to you. Let the complexity come to you. Don't introduce technologies, MCP, RAG, harness engineering and all that. Don't introduce all these things until you find a need for them. So if your solution only requires working with text and outputting text, and it doesn't need to do any kind of real-time search or dig into any type of data source dynamically through RAG and stuff like that, just use a simple LLM call. Yeah, just use a simple LLM call. But if it requires taking actions, that's not just text generation, it requires taking actions, then we'll move to the next question. Is the solution well known and can be expressed as a workflow? Like, do you know the solution part? Do you know the series of steps to solve the problem? If no, or rather, let's explore yes first. If yes, if you know it, then we ask the question again, does the workflow benefit from specialized expertise or domain separation? Does it benefit from specialized expertise? Do agents need to concentrate on different parts, or domain separation? Do you have like a front-end agent? Do you have a back-end agent? Or do you have a reviewer agent? Do you have a writer agent and stuff like that? If no, just go with your single agent. Just go with a single agent. If you don't need to break it down, but it has to perform actions, just go with a single agent. But if you know the solution part ahead, you need to break it down into multiple parts, then use a workflow multi-agent. However, if you don't know the solution ahead, so that's no, we then ask ourselves, does the task involve exploration, unknown solutions, or significant side effects? Do you need to explore? Do you need to, is the solution not known? So do you need to do research? Do you need to explore different parts? Are there significant side effects? Just use an autonomous multi-agent. If yes, use an autonomous multi-agent. However, if you don't need all this and you don't know the workflow, you don't know the steps, just use a single agent still. So single agent here. If you need domain separation and you know the workflow, go with workflow multi-agent. If you know the workflow but you don't need domain separation, use a single agent. If you don't know the workflow and it doesn't need exploration and all those complexities, just use a single agent. If you don't know the workflow but it needs exploration, it benefits from emergent solutions and all that, just use an autonomous multi-agent. So this is your playbook to defending your decision about the type of agentic system you should use. It's simple and straightforward. By the way, now giving credit to whom credit is due, I got the main idea for the framework from this book, Designing Multi-Agent Systems, Principles, Patterns, and Implementation for AI Agents by Victor Dibia. This is a great book on multi-agents. If you want to focus on multi-agents, this is a great book. I still hope to release a lot of courses that I believe is going to be inspired by a lot of ideas that I get from this book. So this book also gave the solid foundation for coming up with the framework that we just looked at. So yeah, that's your decision framework. Don't use a multi-agent system when you need a simple model. Don't use a single agent when you need a single API call. Don't use a workflow multi-agent when you need an autonomous multi-agent. Just use this to guide what you're doing, and it's going to make your decisions simpler. And you can always iterate. You can always expand on your agent. A simple model call can easily expand to a single agent. A single agent can easily expand into a workflow multi-agent system, and a workflow multi-agent system can be redesigned to be autonomous or to work with an autonomous multi-agent system. So yeah, that's the framework. Let me know if you have any questions in the comment section. And like I said, if you want to learn how to build multi-agents, project-based approach, check out my multi-agents course with the link in the description. I've added a discount there. You build real-world projects, a web troubleshooter, you build a job interview pipeline. That one was fun. You get to build an agentic system that runs an interview process from start to finish. You also build a smart travel planner that takes all your travel preferences and generates a full plan for your travel, including budgeting, places to visit, all based on your interests and budget. And you also get to build a home buyer's assistant that can help you figure out where to live based on your specifications, including where you would like your children to school, what budget you have, what type of neighborhood you want to be, and all that. So there's a link to that in the description. And also I will add the GitHub link where you can find all these diagrams so that you can use them as reference. Take care and enjoy building AI agents.